This is Algebra 1, Lesson 19C, Roots. We're going to do example 19.5. Do you remember inverse operations? We've talked about that a few times. The inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. The inverse of division is multiplication. We've done that. What is the inverse of exponentiation? We've been raising things to exponents, right? Like this. 3 times 3 is 9. We talked about how that could be written as 3 to the second power is equal to 9. Well, going backwards, the inverse of that would be taking the square root of 9 to get 3. Remember how I talked about raising it to a second power is talking about squaring? Well, if you take the square root of something, it's undoing the squaring. It basically is saying what number, okay, so square root of 9 would say what number times itself, okay, a total of 2 factors would give me 9. Well, the only number that would work would be 3 because 3 times 3 is 9. Let's look at the next example. We know that 3 times 3 times 3 is 27. That means 3 cubed is 27. So the cubed root of 27 means what number, when I have a factor 3 times, that's how many factors I have, when I multiply them together would give me 27. Well, it would have to be 3, right? 3 times 3 is 9, times 3 is 27, like we said over here. Then we have 3 times 3 times 3 times 3, which is 81. 3 to the 4th is 81. The 4th root of 81 is 3. See how we're just going back and forth, okay? One more. 3 times 3 times 3 times 3 times 3 is 243. 3 to the 5th is 243. These are the same. This means exactly the same that this means. And this would be writing it to go backwards. The 5th root of 243 is 3. What number multiplied times itself, a total number of factors of 5 times, would give me 243, and it would be 3. Let's look at the square root of 9 again. Is there another answer? Okay, let's go back up here. I'm going to erase some of my markings here. Could there have been another answer for that? Some number here that when we multiply it by itself, we get 9. Well, I can think 3 times 3, right? But is there anything else? What if you think about positive and negatives? A positive times a positive will give you a positive. We know that. But what if it were a negative 3 times a negative 3? Wouldn't that also give you a positive 9? So there's another answer to that square root. But when mathematicians use this symbol, they are usually indicating that they're wanting the positive root, which would be 3 in that case. Now, something interesting here. What about cubed root of 27? Let's draw that. Something times something times something, and the somethings are all the same, is going to equal 27. 3 times 3 is 9, times 3 is 27. Let's try negative 3 with this. This negative 3 times this negative 3 would give me a positive 9. And that positive 9 times this negative 3 would not give me 27. It would give me negative 27. So there's not 2 answers for this one. Can you make a conjecture? Can you make a guess as to the next ones? Could we put a negative here? Could we put a positive here? What would work? And the book goes further into detail about these. So if you would like to read more in depth about the signs, you may do that. They do make a note that they say in this book, they will indicate that they want the negative even root when they indicate it with the negative symbol or the opposite. Let me show you what they're meaning here. The square root of 9 is equal to 3. We know that. If they want you to tell them negative 3, they're going to say, what is the opposite of the square root of 9? Okay? Same thing here. So if these are even roots, so I'm kind of hinting at what I asked you a few minutes ago, okay? So here's an even root. This is a fourth root. And if they want the negative one, they're going to stick this out and say the opposite of that fourth root would be a negative 3, okay? That's how they're going to indicate it. And also, I think I said this in a video, but I don't remember. If you have just this symbol that is a square root, okay, that has a 2, and we're going to talk about that just a second, actually, so I'll hold on to that for this page. All right, a little more vocabulary, which was what I was about to get into. The radicand is your number that is under the square root sign, okay? It is what is on the inside, the radicand. So the radicand here would be this, or it would be this, okay? But the root index, or sometimes just called the index, is this little number right there. Now, we've been dealing with these square roots, like square root of 4. What's that? Well, it's 2, because 2 times 2 is 4. I didn't put a little number here, did I? There's no little number there. Well, if there's no little number, you know that it's a 2. We never write, I've seen it a couple times people write it, but you typically don't put a 2 for that, okay? We just know that that's a root index of 2 if you don't put a number. So let's do just a few more. For example, 19.5, the square root of 64, what number times itself? Root index is 2, so there's going to be 2 of them, is going to give me 64. A lot of students, when they start doing these, they'll take half of the number and they'll say, ooh, 32. But 32 times 32, you're talking about way bigger than 64, right? You're thinking adding 32 and 32. But what number times itself would give me 64? Yep, 8 times 8. So 8 times 8 is not the answer. The square root would be 8, because it's saying what number times itself would give me 64. Now I want a fourth root. Okay, this is where it jumps up in complexity. You have to think about this. And I sometimes will draw the little boxes if I don't know it off the top of my head. Or maybe some underlines. You could draw some underlines to show. I know the root index is 4, so I know I've got to have 4 factors, and I know I want the answer to be 16. So if you're multiplying them together, like you are here, you can know that it can't be a very big number, right? So let's start with 5. 5 times 5 is 25. I'm already bigger than the number I'm supposed to get. So it's got to be a small number. What could it be? Let's try 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So what is the fourth root of 16? It's 2. Let's try the cubed root of negative 27. So the root index is 3. I need to think of what 3 numbers, okay, or what one number, when it is multiplied a total of 3 times, is going to give me a negative 27. Well, I have an odd number of factors, and I end up with a negative. That makes sense, doesn't it? So these must be negative. I'll have 3 negatives, which is odd, which will give me a negative product. Now, what number, when I multiply it times itself, a total of 3 factors, is going to give me 27? 2 times 2 is 4, times 2 is 8. That's too small. 3 times 3 is 9, times 3 is 27. There we go. So the cubed root of negative 27 would be negative 3. And D, this negative is on the outside, okay? If it were on the inside, let me go there for just a second. If it were on the inside, you couldn't answer that, because you can't find a negative number times a negative number that would give me a negative result. You can't, that's not going to work. And there's no positive number times a positive number that's going to give me a negative result. So you can't do this. But I will tell you that you just can't do it in Algebra 1. In Algebra 2, you will learn a way to do this. So let's see what this means in this case. When the negative here is on the outside, remember we're going to think about that like opposite. So this is like the opposite of the square root of 81. Well, the square root of 81, what number times itself? It's going to give me 81. That's 9 times 9. So we want the opposite of 9, which is negative 9.